Hey everyone, welcome back to the channel with another Leetcode question. Maximum strength of K disjoint subarrays. This question was asked in today's weekly contest. Let's look at the question. You are given a zero index array of integer nums of length n and a positive odd integer k. You need to select K disjoint subarrays from nums such that their strength is maximum. And we have to return the maximum possible strength. And to calculate the strength, they have given this formula. Now, first, let's see how strengths are calculated. Suppose they have given K. That means we have to select K subarrays. Suppose this is the first subarray. Then we have to multiply it with K. And second subarray is multiplied with K minus 1. Third subarray is multiplied with K minus 2 and so on. So if this is the kth subarray, we have to multiply it with 1. And also, since this is an odd value and this is the odd value, so since they have given k is odd, so this is odd, this will be even, again this will be odd, next one will be even, like this. What they have mentioned extra is, in case of even, whatever the strength we calculate for this subarray, we have to negate this value. That means at the end we have to multiply all with the k plus 1. That means if k is odd, it will become even. That means the value will be even. That means in case of odd, we will not negate. And in case of even, we will negate the value. This is how we have to calculate. Now let's see this example. Since the k value is 3, that means we have to select 3 subarrays. Let's suppose we selected this subarrays. A subarray can contain one element also. Let's suppose we have selected this subarrays. Now, if we want to calculate the strengths, for the first one, it is 3 into 3. For the second one, it will be 8 plus 1 into 2. For the third one, it will be 2 into 1. Now, since this is even, we have to negate this value, right? So it will become 9 minus, it is 9 into 280 minus 18 plus 2. That means overall, the strength of the selected subarrays will be 9, 10, 11 minus 7. So this is what we get for this chosen subarrays. So we have to maximize this. Now let's suppose we choose another subarrays like suppose we chosen this subarrays. Now we 1, 2 and this 3. We choose this subarrays. What will be the strength? Sample 2. So in this case, we will take the summation of this subarray, subarray 1, subarray 2, subarray 3. The summation of subarray 1 will be 3 plus 5, 8, 8 to 10, 10, 6, 16, 16, 8, 24, 25, 34. So it will be 34 into 3 plus this will be 7 plus 3, 10, 10 into 2 plus 8 plus 19 is 27, 27 and 23 is 50. So 50 into 1. And since this is even, we have to negate this value. So it will become minus 20. So overall, we will get 34 into 3 is 102 minus 20 plus 50. So overall, we will get 132. So we can see if we choose different subarrays, we got more strength than the previous one. So we have to choose the subarray efficiently. Now let's see how we can choose. If we expand this formula, what we are doing? Suppose we expand this formula of subarray 1. If there are, suppose the elements are x11, x12, x13, x14. right? And we are multiplying it with k. That means each element is multiplied with x11 into k and doing a summation, x12 into k and doing a summation, x13 into k and doing a summation, x14 into k and doing a summation, like this. And it is done for all the subarrays. Now let's take small example. Now suppose we have 2, 3, 7, -1, 4, 9, and the k value is 2. So for the first subarray, so we will choose the element for the first subarray first. Now we will go and ask whether we want to include 2 in this subarray or not. We have two options. Either we will include or we will not. Suppose we want to include this. So once we include this, so we have to take a continuous subarrays. Either we include only one elements, or we include two elements, or we include more elements. Or in case we didn't choose this two. In case we didn't choose this two, then we will ask 3 whether we want to include this 3 in this subarray or not. So once we select any of the elements, then we have to select the other elements for this subarrays to be continuous. We can't skip and choose different element. So for every element, we have an options whether we want to be included in that particular subarray or not. So we will have two subarrays here. And since we are choosing elements, we are not done with the first subarray. We will first fill the first subarray whether we want to include it or not. Whether we want to include it or not, we will ask. If we want to include it in, then what we can do? 2 into, since this is the first subarray, that means we will multiply with k. This is the actual sum. 2 plus k. Again, if we are including this, then we can do 3 into k. Now we are saying we will not include any more elements in this subarray. So we will go with the next element and the next subarray. Now we will ask whether we want to include 7 in this or not. Suppose we don't want to include. We go again with -1. We will ask whether -1, yes, we want to include -1. Then we will do -1 into k -1. And since this will be an even number, we will again multiply it with -1 to negate the value. Remember. Now we will ask for whether we want to include this 4 in this one. Suppose we included this 4 also. Again, we will do 4 into k -1 into -1. So in this way, for every element and for a given subarray, we can choose. Now, how we will know whether we can include these elements in this particular subarray or not? So it might be a case that we haven't chosen. So suppose there can be a case like 2, 3, 7, -1, 4, 9. Suppose we have chosen 2 in this subarray and we don't want to choose 3. That means we can't fill any of the elements further in this subarray because we have skipped one elements. So if we include other elements, then it will not be continuous. So we will stop. But how we will know whether we can stop there or not? So we will take another flag or we will keep a variable which will indicate that whether we have included any of the elements till now or not. So if the value will be true, that means we have included at least one elements. If the flag value is false, that means we haven't included any of the elements. That means we can't proceed with the next subarray. We have to push any one of the elements in this subarrays. Right? For every element in the subarrays, there is a two possibility. Either it wants to be go in the subarray or it is not included in any of the subarray. And if it is included in any of the subarray, then what is the subarray number? Whether it's k, k-1, which is subarray they have to be included. That means we have two states. For every element, we have two states, whether we want to include it or not. and if we want to include it, in which subarray we have to include. So this can be done using a simple recursion, and we can memorize the solution. Suppose we create a DP state of n, which indicates the number of elements, and k, which will indicate the subarray number, and also a flag, which will indicate whether we have included any of the elements in this subarray or not in the previous iterations. So by this, we can solve this question. If we see the constants mentioned, the constants is itself screaming that I am a DP question, please apply DP on me. Because if we see the value of n into k, they have specifically mentioned the value will be less than 10 to the power 6. If we create a space for this, it should not exceed, like it should be nearly approx 10 to the power 6. Then only we can create a DP state of this much. So they have mentioned like the n into k value will be 10 to the 6. Then by seeing the constant, we must have get a hint like this must be a DP question, because then only they are giving this multiplying condition that the value will be less than 10 to the 6. Otherwise, they wouldn't have given this condition. And if we see the values of n is 10 to the 4 and k is n, if we multiply, if they wouldn't have given this condition, then in the worst case scenario, our n into k would have gone to 10 to the 4 into 10 to the 4. That is 10 to the power 8. That means we don't have so much space to apply dp. But they have explicitly mentioned that n into k is 10 to the 6. That means we can apply dp. Now let's look at the solution. So for this, first we will create a dp state of n into k into 2. That means our dp look like this: n into k into 2. That means it indicates for a particular element of nums, and this indicates the current subarray, and this indicate whether we have already pushed at least one elements in the subarray or not. So it will contain either false or true. True indicates that we have at least one element in this current subarray, else it will be false. So we will be receiving three parameters: I, that is the current value of the array; k, that is the current subarray; and this flag value, which indicates whether we have at least one elements in the subarray or not. So when we will terminate this, since if we see we are calling the subarray value from k to 0, that means if the k value is 3, we will first push elements to 3, then 2, then 1, and then gets down to 0. And if the value is 0, if we are at k equal to 2, that means we have already filled the elements for k subarray 3. And if we are at k equal to 2, that means we have filled the elements for k. If we are at k equal to 1, that means we have filled the elements for k equal to 2. And if we are at k equal to 1 and flag is true, that means we have at least pushed one elements in this subarray. And if that is the case, that means now we can terminate. Now we have satisfied all the conditions. We have three subarrays and we have calculated the sum. So this is one case when our value is 1 and flag is true. Else our value is we are at k equal to 0. In both the case, we can terminate. Right? So this what I've written the termination condition. Now, if we have already calculated the value for this given state I, k, and flag, we will return then and there from the TP. Else, we will calculate. So for current value, how we are calculating? We will multiply the current value of the array with the k value. And if the k is even, we have already checked. that if the k value is even, we have to negate the value. In this case, we are negating the value. We will call the recursion call. What are the conditions? So if we see, if we will first see whether our flag is true or false. If it is true, that means we have at least one elements in the subarray. If it is true, and if it is false, that means we don't have any of the elements in the subarray. Subarray. If we have at least one element, let's see first for the false condition. If we don't have any of the elements in the subarray, then what we will do? We have two options for the current element from nums. Either we can choose this element to be a part of this subarray, or we can skip. If we choose this element to be a part of subarray, that means at least one element we got for this subarray. In that case, either we have two options. Either we can move on to the next subarray, that means we can decrement the k value, or we can stay at the same subarray to push more elements in that subarray. In this case, now once we choose any of the values, we will change the flag value. Now we will change the flag value to true. That means it will indicate at least one value we have in this subarray. Or in case we don't include this element to be a part of subarray, in that case, we will stay at that particular subarray. We will increment the pointer of the array, and the flag will still be false. That means it indicates that we have not yet included any of the elements in this subarray. That's what this flag is doing. If flag is zero, that means if flag is zero means we haven't pushed any of the elements in this particular case subarray. Now, once we include these elements, we have incremented the pointer of the array, and we have given an opportunity, like if you want to include more elements, you can include. And now the flag value, is changed. If you see, now we have changed it to 1. Or if we don't want to include this, then our flag value will still be false, and we will just increment the pointer of the array, and we will stay at the same subarray. Now, if we have already included any one of the elements, that means we have two options. Either we can move on to the next subarray, or we can push the current elements in the current subarray. Now, suppose if we push the current element in the current subarrays, then we will just increment the pointer, and we will stay at that same subarray, and our flag value will still be true. If we are moving on to the next subarray, that means our k value will be decremented now. And again, we will reset the flag, indicating that we haven't included any of the elements as a part of the subarray. And at last, we will return the maximum of this value. I hope the problem statement and solution is clear. So solution was pretty straightforward. If you have analyzed the question and the constraints during the contest, you have got the hint, like the DP solution can be applied for this question. If you see, the solution is not that difficult, and this solution is an accepted solution. And the time complexity for this solution will go for n into k into 2. And space complexity is also O of n into k into 2 in the worst scenario. And they have already mentioned that n into k is maximum 10 to the power 6. That means in the worst case scenario, it is going 2 into 10 to the power 6 only.